All right, difference quotient. Let's review this. Now, that review that we're about to do is on test 2. So, for example, suppose that f of x is 5x minus 7. All right? And let's suppose I want to find this. Remember, this part's on test 2. Suppose I want to find a f of negative 5. What are you going to do?
Substitute the x for -5.
Wherever you see the variable x, you're going to substitute negative 5. So this becomes 5 times negative 5 minus 7. So that would be negative 25 and a negative 7. So what is f of negative 5? Negative 32? Okay. So remember what that means? That means that when x is negative 5, what's my y value? Negative 32. And that's going to be important tomorrow night when we go back and talk about even and odd functions again. This notation right here. So we've talked about this before, but that means that when x is negative 5, my y value is negative 32. All right, so then we also did this. We also did find f of 2x minus 3. So this time I'm evaluating f of x at an expression, a variable expression. In part A was a numerical expression. So I substitute a number, I ended up with a number. Here I'm going to end up with a variable expression because I'm substituting a variable expression. But again, just like we did the 5, wherever I saw the variable x, I substituted what was inside that parentheses. Negative 5. Here, what's inside that parentheses? What's inside the parentheses? 2x minus 3. So wherever I see the variable x, I'm going to substitute 2x minus 3. So I get 5 times what? 2x minus 3. Notice a parentheses. And then I'm going to subtract what? Minus 7. Right? And then you have to know that you got to simplify this. So you can distribute. So that becomes 10x minus 15 minus 7. So therefore, what do I get when I combine like terms? 22. So in the answer, you're going to say f of 2x minus 3 equals blank. What are you going to put in the blank? 10x minus 22. Okay? All right, well, now let's suppose this. Let's suppose we had g of x equal 2x squared minus 3x plus 4. This time it's quadratic. F of x was what kind of function that we just did? Linear. This time it's quadratic. So let's find g of, let's say, x minus 3. So where we see the variable x, you're going to substitute what expression? X minus 3. And I see it twice. I see it here and here. And so this becomes 2 times x, and what do I substitute to x? In parentheses, and what do I do to that x minus 3? Squaring it. Minus 3 times x, what do I substitute? All right, in parentheses, and then plus 4. And now I've got to simplify all this. Now be careful, and we talked about this before, are you going to distribute the 2 first? No, the only time you can distribute, just like we did here, is if the exponent of that expression is raised to what power? This has to be, if I'm going to use distributive property, that expression is in parentheses has to be raised to what power? The first. This is not being raised to the first. This is being raised to the second power. If that was the first, then I would do what? Distributive property. Okay? So distributing the 2 is incorrect. You have to do what first? FOIL first. So what I would do, because that breaking down into steps can be important when we actually get into the difference quotient. So make sure you're not doing everything in this little space right here. Do it in little pieces. So what I gotta do is I gotta find out what this x minus 3 squared is. So let's go off to the side and figure out what x minus 3 squared is. And when we talk about the difference quotient, that's gonna be important. So I gotta figure this part out. Well, what does this mean, x minus 3 squared?
X minus 3 times x minus 3.
Yeah, now remember guys, this is on test 2 right here. All right, so that means x minus 3 times itself. And if I FOIL, that becomes x squared. What's the outer?
3x. Or negative
Minus 3x. The inner is also minus 3x. And what's the negative 3 times the negative 3? So what is x minus 3 times itself? And that goes here. So this trinomial has to now be multiplied by what? By 2. So then what I would then do is, so and when we do the difference quotient, you're going to see this idea again, the way I'm doing this. So it'll be 2 times now x squared minus 6x plus 9. And then let's go ahead and distribute the negative 3 here. That becomes what? Plus 9 and then plus 4. All right, let's distribute the 2 now. That becomes 2x squared minus 12x plus 18 minus 3x plus 9 plus 4. And therefore, what's the answer? Combine like terms, 2x squared minus 15x, and then what's 18, 9, and 4? 31? So your answer, you'll say g of x minus 3 equals blank. And what's going to be in the blank? 2x squared minus 15x plus 31. Okay? All right. Now, let's talk about the difference quotient. Difference quotient. Most of you probably don't remember the difference quotient. If you remember, it's probably because you remember it from advanced math in high school. But let's talk about the difference quotient. All right, so difference quotient. Now this is going to be important in calculus, though. That's where it comes into play. It has something to do with derivatives in calculus. All right, so difference quotient. All right, so this formula, and I'm not telling you what it is yet, but this formula computes the slope of the secant the secant line through 2 points on the graph of a function. Okay? So the difference quotient computes the slope of the secant line through 2 points on the graph of a function. Now, in here, you just have to know how to use the difference quotient. It is next semester that you're actually going to have to understand what is it. So here it's more of a plug and chug. Next semester, that's where the understanding is going to be built.
So
All right.
what's the secant line?
Okay, so good question. What is a secant line? All right, so I'm going to draw a circle right now. And remember, this circle is not a function. But I'm going to go ahead and draw a function instead. So let's say I'm going to draw this parabola right here. let's talk about tangent line for one first of all. There's a tangent line and there's a secant line. So next semester, when you talk about the difference quotient, you're going to see that this secant line, as x gets bigger and bigger and bigger, becomes a tangent line. So a tangent line, there are an infinite number of tangent lines here. So notice this is a tangent line. This is a tangent line.
T-E-N-T, tangent?
Yeah, T-A-N-G-N-T. This is a tangent line. So notice that a tangent line, and there are an infinite number of those, because there's how many points on this parabola? An infinite number. So a tangent line is a line that touches the graph only at one point. That would be a tangent line. Now, we're not talking about tangent lines in here, but it goes hand in hand with secant. A secant line is a line that intersects the graph how many places? Twice. So that would be a secant line. Remember, the definition is a secant line through 2 points. Okay, now that's a secant line. How many secant lines are on here? How many secant lines can I draw? Let me rephrase it. An infinite number. Okay, there's an infinite number. All right. So this difference quotient that you're about to see the formula for, it measures the slope of the secant line. Now, we've talked about the slope formula. Slope formula is rise over what? Run. That comes in play as well.
We just keep adding to it, don't we?
Yeah, we do. Next semester, you're going to add some more to it.
And we're not that difficult.
So let's talk about the formula for difference quotient in relation to the secant line. I'm going to go ahead and redraw this function. Let me go ahead and use this function instead. All right, so look at this function. And let's say this is my secant line right here. All right, so you see that secant line intersects the graph at this point. I'm going to call it A, and at this point, I'll call it B. All right? Let's suppose that this x coordinate right here, I'm going to just call it x. And this x coordinate right here, this right here. So listen to me carefully so you'll understand. If this right here is 5, right here, and this right here is 15, then I can say this x coordinate is 5 plus what? 10. Good, because this distance is 10. If this is 1 and this is 7, then I can say the 7 is 1 plus what? 6. All right. If this is x and this distance here is h, then this x coordinate is x plus h. Very good. All right. So in the formula, you're going to see an x plus h. All right. All right, now, let's talk about this y coordinate right here. So this right here is the point, listen carefully, this is the point x, and remember, this is my function f. I don't know what x is, but if whatever x is, I would substitute into the function, right? And based on what we did earlier, let's suppose this was my function making it up. So if I want to find f of negative 5, if I want to find what y is if x is negative 5, I said f of what? Negative 5. So in this case, this x coordinate is denoted as x. So how will I write my y coordinate? How can I find my y coordinate? If my x coordinate is negative 5, how do you find your y coordinate? Notation, guys. You tell me notation. We said let's find what? F of negative 5. If x is 3, and we'll find my y coordinate. Remember, this is your y coordinate right here, right? This is your x, this is your y. So if my x coordinate's 5, then I would say let's find f of 5. If my x coordinate is 2, I would say let's find f of 2. If my x coordinate is x, I will say let's find. Very good. That's all I wanted you to get to. So that point A, my x coordinate is x, and my y coordinate is represented as what? F of x. Let's talk about point B. Point B. Well, what is my x coordinate in point B? X plus h. Very good. How will you find your y coordinate? F of x plus h. All right. We're almost there. F of x plus h. Now, remember, the difference quotient is the slope of the what? Secant line. So here's my secant line. Do I know 2 points that line that secant line? Yes, I do. A and B. So this is my x coordinate, my y coordinate, x coordinate, y coordinate. So let's use the slope formula. So the slope of the secant equals rise over run. The rise, you subtract which coordinates? The y coordinates. So let's start with this one. So this y coordinate is what? F of x plus h minus this y coordinate, which is f of x, divided by the change in x coordinates. What's this x coordinate right here? X plus h minus this x coordinate, which is x. What do you notice about your denominator? What is that denominator simplified to? H. So this is f of x plus h minus f of x all over h. This right here is the difference quotient.
So when you write difference quotient, do you have to put M of?
No, you just need to know that it's a slope, but you don't have to know it's a slope because on the for us for this course next semester we have to know it is the slope. But for this course, it'll just say find the difference quotient of this function. So you just say difference quotient equals f of x plus h minus f of x all over what? H.
I'm glad it's still the next test.
But you do have one in your final. You do have one in your final, and it is quadratic. Yes.
If you say it's gonna be multiple choice, like you have to remember the order or?
No, it's not multiple choice. Your procedure is going to be, I need to do this, I need to do this, I need to do this. Okay?
You have to do that.
All right. Now, I could have just gone ahead and told you this is the formula without doing any of this, but for some of you, you need to know, because there are at least 2 of you taking business calculus next semester, you need to know where this is coming from. All right, so this is the idea.
I'd hate to see full-blown calculus.
All right, so here's the way it's going to be stated. Find the difference quotient of a f of x, which equals 7x minus 2. So we're going to start with a linear function. The linear functions are easier than the quadratic, and all we're doing in here is a linear quadratic. You could find the difference quotient of any kind of function. Square root, radical, any of those. Cubic, polynomial, but those become more complicated. So we're only dealing with the two easier kinds, linear and quadratic. But the one in your final is going to be quadratic.
Thank you for letting us know. Is it the harder of the two?
Yeah.
Thank you so much.
You're welcome. I always try to make you happy.
You are great.
So let's talk about the linear one first. All right, so first of all, you have to know and I will give you the formula, but next semester they may tell you have to know the formula on your own. But the formula is this: f of x plus h minus f of x all over h. Now the linear one is not complicated. The quadratic one is not complicated either, it's just the steps. It involves more steps. So remember when we did this one a while ago? When we did this a while ago, you had to do what? FOIL. So you have to FOIL because don't you see a binomial right here, x plus h? Here you had a x minus 3. That's going to be the complicated part. So make a connection between this and the one that you're going to have on test 2.
That was test 3.
I'm sorry?
It was on test 3.
This is test 3. All
Part of it is on test two.
right. Make sure you look at your
Oh, well,
your study guide, okay? All right.
She started this was on test 3.
All right. So here are the steps. So you're going to write it like this. You're going to say step 1. You remember when we did this one? We did this right here. When I substituted in, the first thing I said was on the side, figure out what this binomial squared is. Okay? All right. So first thing you're going to do is you're going to find this part of the difference quotient first. So that'll be your step 1. So I'm going to say find f of x plus h. Doesn't that first part, so you break it into little pieces. So doesn't that first part look like the one we just did? So that step 1 is going to involve this right here. That's that step 1. Okay? All right. So remember what this means. Wherever you see the variable x, what do you substitute? X plus h. So this becomes 7 times what? X plus h minus 2. Okay? Now, this is not a binomial squared, so what's the next step? Distribute. So it becomes 7x plus 7h minus 2. Now remember when we did this one, we'll go back and cover this up. When we did the linear one, I said 5 times, oh, here it is. I said 10x minus 15 minus 7, and then what was the next step I did? Combine like terms, and I was done. Here, though, what do you notice? There aren't any like terms, so you're done with the step 1. That's what makes the linear part the easier one. Now, I found step 1. What's the next thing I have to do with step 1 that I just found? Subtract f of x. So now I got to do this part. So that's going to be your step 2 right here. So then you're going to say step 2 is where I take what I got in step 1 And what is it I got in step 1? 7x plus 7h minus 2, and then I got to subtract f of x. All right, now you got to remember some stuff we talked about since day 1. Is this correct that I'm writing? No, it is not. I am not subtracting 7x subtract 2. I'm subtracting what? F of x. And what is f of x? So what should I do? Parentheses. Okay. And now let's put that all over h. Okay, so that's where I'm at. So step 1 is just finding that first little part of the numerator, and then step 2 is just putting it all together. Now look at the numerator in step 2. What else can I do to that? What can I do? Distribute. Okay, so it becomes 7x plus 7h minus 2. What else? Minus 7x plus 2 all over h. What's the next step? Combine like terms. Now notice what's going to happen when you combine like terms. You're not going to understand why. Next semester you will. But what happens when you combine like terms is this. Any term that doesn't have an h should cancel out. 7x minus 7x. A negative 2, a positive 2. And what's left? 7h over h, which reduced is what? 7. So the answer, you're going to say difference quotient equals what? 7. Now that does mean something. It does mean something. The 7 does mean something. So remember we were talking about that the secant line is a line that intersects the graph in 2 points. So notice that no matter what 2 points I use, what's going to be the slope of that secant line? 7. But for us right now, you need just to remember that whenever you do this part right here, any term that does not have the variable h, you better cancel out. If you don't, you did something wrong. Okay? So let's do another one. We're done with this one. That's the answer. So the difference quotient, you would say f of x plus h minus f of x divided by h for this function equals what? 7. All right? Now, I'm just going to go ahead and say this because the one in your test is not going to be linear and the one in your final is not linear as well. But remember, when we wrote this in, well, if you look at this function right here, in this slope-intercept form, y equals mx plus b, what is this 7 right here? A slope. What do we end up with? The slope. And the reason why this linear one's so easy is because no matter what 2 points you use on the line, isn't it the same line? And the slope of the line, no matter what 2 points you use, is always going to be the same. Quadratic's not, though. All right. Let's look at one more with a linear one. B. Let's suppose this time that f of x is negative 5x minus 6. And we'll find the difference quotient. So I say find the difference quotient. First of all, what's the formula for difference quotient? F of x plus h minus f of x all over what? H. And all you got to do now is just plug and chug. This is linear, so that's easy. The one of your tests, though, test 3, is quadratic. All right, so do it in steps. Step 1, what is step 1? Find f of x plus h. So wherever I see the variable x, what do I substitute? X plus h. So tell me what you write. Not 5, negative 5. Parentheses, x plus h minus 6. All right? What's the next step? So remember, all I did, remember it helps if you underline this and substitute that into x right here. So if you need to draw those little lines, do that. Now what's the next step? What's the next step? Distribute. So what does that become? Next step is going to be combine like terms. What do you notice? Already like terms. So you're done with step 1. For the quadratic one, your step 1 is going to be the more involved one. After that, it's easy to deal with. Okay, now step 2 is where you put all the pieces together. So that f of x plus h, I just found. What is it? Negative 5x minus 5h minus 6. And then I've got to now do what to what I just found. Subtract f of x. So I got to subtract in parentheses, what is f of x? Negative 5x minus 6. And all that's being divided by h. You're almost done. What's the next step? Distribute the negative 1. So it becomes negative 5x minus 5h minus 6. What else? Plus 5x plus 6 all over h. If I'm doing this correctly, every term that does not have an h better cancel out. Negative 5x, positive 5x is 0. Negative 6, positive 6 is 0. What's left? Over h, reduce, the h's divide out. What do I get? What is the slope? Negative 5.
Would it always be the slope?
If only for linear. But the one in your test is not linear. So you're going to say difference quotient equals what? Negative 5. All right. So that's the linear part. That's the easy kind. That's easy kind. I want to do one quadratic, and then tomorrow I'll do one or two more. But I just want to get started on that one little part, and then after this, I'll give you the in-class worksheet. You can work on your the worksheet I just gave you. All right, you ready for the quadratic one? This is where you say yes. All right, f of x equal. It's like about to get on a roller coaster. Thrill of your life. 2x squared minus 3x plus 2. So I'm going to find the difference quotient for this quadratic function. Now remember we talked about secant versus tangent? So there are how many secant lines? How many secant lines can I draw in this problem?
Infinite
Many,
number.
Infinite number.
many.
Okay, infinite number.
3 on
But when x becomes bigger and bigger and bigger, or h becomes bigger and bigger and bigger, those secant lines become tangent lines. And remember that quadratic I drew earlier? And I looked at all these tangent lines. Remember, tangent line is a line that touches the graph how many times? At one point. And there are how many of these tangent lines? You have a number. What do you notice about the slope of each of those lines? Are they the same? No, they're different. When we did this linear one a while ago, when we did the linear one, and I look at all these tangent lines. How many tangent lines are, I'm sorry, secant lines. I looked at all these secant lines. How many secant lines are there? An infinite number. But they all represent the same line. So the slope is the same for each one. So that's what we said, remember earlier was -5 or 7, whatever it was. Here, you can see what it's going to look like. It is not going to be a number. The answer here, the difference quotient was a number. Here, it's not going to be a number. It'll be a variable expression. All right? All right, so let's get started. Difference quotient, f of x plus h minus f of x all over h. What is step 1? Find f of x plus h. All right, let's find f of x plus h. You're going to notice that it's going to look just like the one we did earlier. It's going to look just like this. That's going to be your step 1. All right, so wherever I see the variable x, what do I substitute? X plus h. So it's very similar to what you have on test 2. So if you want to find g of x minus 3, wherever you saw the variable x, what do you substitute? X minus 3. And then you did all your computations, all your manipulations. Except instead of x minus 3, I'm substituting what? X plus h. All right, so here we go. 2 times what? X plus h squared. Minus 3 times what? X plus h. And then what? Plus 2. It looks just like this one. Make sure you compare the two. Then what was the next thing I did, if you recall, in that very first problem we did? Okay, so I took that x plus h squared and I went off to the side. You need to do that. X plus h squared. Go off to the side and rewrite it as x plus h times itself. And then FOIL. What's x times x? What's the outer? What's the inner? And what's the last? What's the next step? I get x squared, 2xh, plus h squared. So you'll notice that every time you have this quadratic, every problem you're going to see, that x squared, when you substitute x plus h squared, every time, isn't it always going to be this expression right here? Yeah. So if you can remember that x plus h squared is x squared plus 2xh plus h squared, then all you do is here just say 2 times what? X squared plus 2xh plus h squared. Now remember, let's compare it to the one we did a while ago. Once I found this x minus 3 squared, I then substituted that here, right? And then the next thing I did was I distributed the other part. So I'm going to distribute the what here? -3. So it becomes minus 3x, and then what? Minus 3h, and then what? Plus 2. And then next I do what? Distribute the 2, and I get what? 2x squared plus 4xh plus 2h squared. Come on. Minus 3x minus 3h plus 2. That's where I'm at. So when we did the other one a while ago, it is time consuming. You got to practice on this. When I did the other one a while ago, what is it I then do at this step? Combine like terms. Are any of these terms like terms? No. So I'm done with that part. I'm done with step 1.
Step 1, 10 miles.
Now, step 2.
No, Oh,
So step 2, remember all I found was what part of the difference quotient? First part. So I'm going to rewrite all this over. 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 2. And then I subtract, in parentheses, what do I subtract? F of x. What's f of x?
Oh, you gotta go all the way back up here to your front.
you're running out of room.
I am running out of room. All right. All over what? H. Couple more steps and you're done.
Yeah.
What's the next step? Distribute the negative. All right, so I'm going to distribute the negative. So here I go. 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 2, and then what? Minus 2x squared plus 3x minus 2 all over what? H. Stop complaining now. Just deal with it. Complaining is not going to do any good.
Because it's not that.
Not going to do any good. Now what are you going to do? And at this point, what should happen?
Everything that don't have an H cancels out.
That's right. So look, 2x squared, there better be a what? A negative 2x squared. That has an H. That has an H. A negative 3x, that better be a what? Positive 3x. That has an H. A positive 2, that better be a what? Negative 2. All right, now listen carefully. Everything that's left better have a what? H. So I get 4xh plus 2h squared minus 3h all over what? H. Now remember, when we did the linear ones, we reduced at the end, right?
Right.
But that one was easy because there was only one term. Here, how many terms are in the numerator? 3. What I would then do is this. I would rewrite each of those as separate fractions. So I would say 4xh divided by what? H. Plus 2h squared divided by h. Minus 3h divided by h. And therefore, tell me what the answer is. 4x plus 2h minus 3. There's your answer. That does mean something for those of you next semester. All right. You want to do one more, and then we'll do a couple tomorrow, and then we'll move on to graphing exponentials again. So tomorrow we continue on with exponentials. All right, let's do one more with quadratic. All right, so here we go. It is tedious. Notice that on test 3, this will be on a page all by itself.
You might want to put an extra blank page.
Yeah.
I hope you might mark points off. I don't have to sign it somewhere at the beginning or end or something like you normally do. 'Cause
F of x plus h equal, notice I'm ignoring you, equal negative 3x squared plus 2x minus 7. All right, what kind of function is this? All right, there's your tedious part. Okay, so first of all, your directions will say find the difference quotient for this function. So the formula is f of x plus h minus f of x all over h. Here's your difference quotient. Now you know where it comes from. We did it at the beginning of the class. I drew that curve with a secant line, and you know what that formula means. It has to do with slope of a secant line. All right. What's step 1? Find what? F of x plus h. So wherever I see the variable x, what do I substitute? X plus h. All right? So you should have a background now. So now it should be a little bit easier for you. So then we get -3 times in parentheses. What do I put? No, I don't. Oh, I see what you're doing. All right, so that's a good point. What was she putting? She was already remembering that x plus h squared equals what? X squared plus 2xh plus h squared. Okay, that is true.
Most of us not ready for that.
But most of you will not remember that. So if you're the case, and most of you will, so now if you don't remember, don't guess at what needs to be there, because then your whole thing is wrong. Okay, so what I would then do though is I would just go ahead and write in the steps. So this is -3 times x plus h what? Squared. Plus 2 times what? X plus h, and then -7. Now, remember the previous two that we did, you go off to the side and you figure out what x plus h squared is. And it's always going to be x plus h squared all the time. So x plus h times itself. FOIL. What's x times x?
X squared.
What's the outer? That's where you say xh. What's the inner? Again, that's where you say xh. What's the last? H squared. What do you then do? Okay, when you combine like terms, you get x squared plus 2xh plus h squared. Right? Now, what do I do with what I just found? Plug it back into x plus h squared. So now this becomes -3 times what? X squared plus 2xh plus h squared, and then distribute 2x plus 2h minus 7. Now what's the next step? Still in step 1, what's the next thing I do? No. It's still in step 1. What do I then need to do? Look at what I have. Distribute -3. So it becomes -3x squared. What else? What else? Good. And then write everything else over. Now there's nothing you can combine here. No terms are alike. All right, so we're done with step 1. The rest is easy. You just got to make sure that your step 1, all these terms are correct though. The rest is easy. Step 2. Step 2 is where you're going to put this all together. So remember, I found f of x plus h. What is it? It's all these terms. So you just write it over. So what do I put? Very good. And then minus, and you're going to subtract the f of x, which is that trinomial. So what do I write? In parentheses, by the way.
3x squared plus 2x minus 7.
Yeah, I'm running out of room here. All over h. You're almost done. What's the next step? Get rid of the parentheses, distribute the negative. And when I do that, I'm going to get in the numerator -3x squared minus 6xh minus 3h squared plus 2x plus 2h minus 7, and then what? Plus 7? All over what? H. If you're doing this correctly, at that point, what should happen?
Everything that doesn't have an H.
Every term that doesn't have an h needs to cancel out. So -3x squared, there better be a positive 3x squared. There is. 2x, there better be a what? Negative 2x. There is. H, -7, there better be a positive 7. Now what's left in the numerator? 2h all over what? You're almost done. Write separate fractions, or if you want to, go straight to the answer.
Separate fractions.
You want to write separate fractions right now? Okay. Negative 6xh over what? H. Minus 3h squared over what? Plus 2h over what? Now give me the answer.
Negative 6x minus 3h plus 2.
Plus 2. So that's your difference quotient. So that is f of x plus h minus f of x over h. It isn't that bad when you do a few more. It's the tedious part is this part right here. It's really not anything difficult to deal with. Okay? All right, so we do a couple more with this tomorrow, and then we're done with this. And then we can continue on talking about exponential functions, graphing exponential functions. Okay? All right, so let me